Yeah, so lesson learned, trying to design something you've never designed before, then to use unfamiliar software and hardware to make it a reality isn't always smooth sailing. But here I am at the finish line, so let's get back to the morning of the race itself. It was simply another day in my 3D printing and YouTube journey when I received a rather unique email, one from a company I had actually heard of, Makera. Now, heard of is a relative term. I was unironically about 20 review videos deep into their latest machine, the Carvera Air, which is not a 3D printer. Quite the opposite actually. Considering somebody already had their hands on one, I may or may not have been jumping up and down upon reading Makera's email. This was a proper big deal. I could start making complex parts in-house using non-plastic materials, controlling every step of the production chain. This would save time, build skills, and ultimately mean better projects for you guys. So essentially this was a win-only situation. But what could I do for Makera in return? I'm just not overly keen on reviews, their tone and requirements are better suited for others, so that immediately isolated the correct answer, a project video. It was then a process of elimination until I landed on something a little bit crazy, a little bit relevant, and hopefully a little bit achievable as well. Oh, and beneficial in terms of learning, but we'll certainly get to that. Let's get to briefing after a quick disclaimer. Makera provided the machine bundle for this video, no money changed hands, but there is a paid ad read for PCBWay between these two timestamps. Please take this into consideration. How familiar are you with this? The humble stepper motor, or more specifically, the humble and very common Nema 17 stepper motor. Over the years, a plethora of extruder designs have used it, and recently we've started seeing the smaller but still capable Nema 14 slither its round and compact self into even more designs. The most notable, I'd say, is the Orbiter V2, a design by Dr. Robert Larynx and manufactured by LDO Motors, which uses the Nema 14 and a lovely planetary gear set to boot. Let's go back a moment though to the square Nema 17s for a bit. There are dozens of extruders that utilize them, and even your 3D printer likely uses them. So I want to take inspiration from the legendary Bondtech BMG extruder, or at least the clone I have on hand, and scale the design down to use a motor that's more cute than capable. Oh, and only using subtractive manufacturing to do it. Spoiler alert, I've never used a CNC machine before, nor the required CAM software, so this will be interesting. I'm Tommy Houghton, and welcome to building the smallest 3D printer extruder using only the Makera Carvera Air. After carefully bringing this monster 50 kg box up just shy of 70 steps, it patiently waited until today to receive some much needed attention. Well, there it is, the Carvera Air. That's one unboxing down, now there's 3 more to go. Because Makera sent over this machine for free, I don't want to just sit here and do the bare minimum, so I've personally invested into more equipment to make my workflow as good for subtractive as it is for additive. This includes an air compressor and a shop vac used for removing chips and removing chips respectively. This will be useful in the long run. Let's now unbox the second most important part, the smallest stepper motor I have ever seen. I bought the motor myself for $45, so I could probably get more than 3 regular Nema 17s for the same cost. No. It's so cute! I likely bought a model with a low current and torque rating by lack of research, so I'm extremely curious to see how well it will work, if at all. The current rating is only 0.2 amps. I was at a value 25 times higher on my Nema 23s just the other day. Moving on, let's take a look at the parts haul that I've gathered. Starting off with 4 plates of aluminium, followed by 3 more plates of aluminum, followed by 1 plate of aluminium. We don't talk about the large aluminum blocks I also bought. Next, 3 sheets of POM plastic, and 1 very small plate of the legendary high performance engineering thermoplastic polymer, polyether ether ketone. While it's still plastic, filament spools of this stuff are like $700 a kilogram. It makes sense as this material is peak in more ways than just its name. Apparently it's easy to machine though, I mean it is still plastic, right? Surely there won't be any unforeseen challenges and I totally end up using those materials. some metal rods for gear machining using the rotary axis, since there's no lathe in this shop and won't be for a while. I'm also deathly curious as to how easy this could hopefully be, but I may be a bit too confident there. Wrapping up our materials, we have some acrylic blocks. I grabbed these to make the chassis pieces, or such, of the extruder itself. Cheap, accessible, and transparent plastic is clearly better. Next time I'll use cast plates of acrylic though, but as you'll soon see, these current pieces were both a blessing and a curse. In terms of components, this is where it gets quite fun. We have some of the smallest bearings I've ever seen, little thumb screws, M2 heatset inserts, a pack of fitting M2 hardware, a bag of springs, some lovely 3mm pins, and that pretty much wraps up the components. But here's where it gets especially interesting and perhaps a bit silly. A standard 1/8 inch bit, a 2mm one, and a 1mm variant as well. Then some 10° 0.1mm engraving bits, a 0.5mm ball nose bit, and finally some 0.4 and 0.2mm bits respectively. Like, how do I even level the probe? How do I even get it to calibrate without breaking it? I was scared even taking it out of the case. I'm afraid of breaking them just by looking at them. Bits this small call for some very fast spindle speeds, and while the Carvera Air can do a good maximum of 12,000 RPM, for this application, more would be better. There are still a few boxes left that I forgot, including the 4th axis rotary module, which was a key factor for even considering this project. This is a very fun and very solid assembly. I'm looking forward to getting used to it. In this bundle there is also a laser module, which I don't intend to use this time round, a huge set of tools for operating the machine and its overall workflow, alongside the materials for the tutorial projects, which I'll be saving for the future. There was also quite the assortment of bits, which I was very pleased about. Whoa! Makera's bit offerings are so good, I might not even need to use my own. There are some pretty interesting ones included. To organise the many bits included in the extended set, I 3D printed this bit organiser from printables on the K2 Pro that will store all the bits we have with room for more. 3D printing really does go hand in hand with CNC machining, especially when it comes to part fixturing, but we'll get to that. First, we need to move our bits to the new holder. And that's that. Now that we're mostly set up, it's time for the next stage. If you're interested in trying CNC machining but you're unsure about buying a machine just yet, then PCBWay could help with that. They offer a brilliant variety of machinable materials, min and max part sizes that can adapt to almost any project out there, and scalability from one-off prototypes to tens of thousands of parts. Proper stuff. They offer fantastic 3D printing services as well, with capabilities ranging from SLA, SLM, SLS, and more, and laser cutting too, which really opens up a world of possibilities. If you're looking for a way to elevate your ideas even higher, then PCBWay is worth considering. There'll be a link to their site in the video description below. Thank you, PCBWay. Well, we're at the computer now, so it's time for a change of scenery and pace, and jump into the most professional computer-aided design software there is. Autodesk, Tinkercad. In all honesty, I do miss using it though. S tier. We'll be using Fusion 360, since making this extruder isn't as simple as exporting the files as an STL, scaling them down to 50%, and then sending them off. CNC machining places a higher emphasis on the slicing of the actual G-code, which requires careful toolpath generation to prevent that. Before we worry about that, it would be wise to design an extruder that's similar to the BMG, could mount to the Nema 8, uses the hardware we have and can make, and preferably isn't too complicated, since my CAD skills are subpar and my CAM skills are non-existent. So let's import the motors.step file and the full-size BMG extruders file too, and get to work. I spent a couple of days on the design, with the hardest part being the gears, since I had never designed any before and the scale I was operating at wasn't exactly making things easier. After some time, I settled on a 15-tooth gear and a 45-tooth gear for a 3:1 ratio. The design is very similar to the regular BMG, consisting of a back frame piece, a front frame piece, an arm, and then the corresponding pins, gears, and hardware. On the screen, it was looking very nice, despite being a version 1. Alright, we're now up to the part that I have absolutely zero experience in, and I may or may not have refused to do the tutorial projects, let alone cover them in this video. So I think it would be wise to start with the simplest part first, so that's the plan for now. Unlike traditional slicing for 3D printing, programming for CNC using CAM is a bit more involved, and while it's not overly complex when doing simple parts, a new workspace is always a bit intimidating. Bundled with the Carvera Air is Makera's own CAM software, aptly named Makera CAM. I binged a few videos on it, but it's a very simple piece of software overall. You import your chosen part, choose an operation and bit, and a toolpath is then generated. For simple parts, this would have worked fine, but the issue here was that some of my parts required machining from 3 sides, like the next part, which is the tensioning arm. So jumping straight into Fusion 360 was my best bet. I did this right after my first attempt on the arm part. As of this video's release, I'm still yet to watch a tutorial on how to properly use Fusion CAM, so if anything, that's reassurance that it's not as hard as it seems. That being said, I'm still very inexperienced and have lots to learn, so I'm hoping my mistakes will be useful for some. Well, just gotta go for it. Whoa, it's moving. It's moving. I'm switching to this block of epoxy. And now, while that's not going anywhere, it's rite of passage for something like this to come off at least once. Hopefully not this time though. And now we've successfully connected to the Makera controller software, and let's just push some buttons. Well, that positioning looks about right. And it should prompt me for a tool change before it actually starts. Splendid. Okay, it's a bit less scary than I thought. That's good. I'm just gonna keep a close eye on it. Wait, I've just checked something. Hold on. It says it's got 11 hours to go. I hope that's wrong. It's just machining air now. I'm not sure what it's thinking. That's why I did a test piece. Perhaps having the dust shoe attached would have been a good idea. Well, that seemed to complete just fine. Let's clean it up, and then I think we flip this over. Oh, and there's that little part as well. Emphasis on the little, it's as big as a finger. I've never felt, well, I haven't felt like this in a long time when dealing with new equipment. Look at that beautiful part. It's almost like it's made out of wood. Okay, that's looking promising actually. So I'm a bit concerned with how low the bit is going. It's going in all the way up and it's just hit the thing. Okay. I was wondering when that would happen. Yeah, that's really annoying. I need to figure out how do I do this? Well, this is our part. It's not complete. The holes didn't come through all the way, which is something I've learned how to fix. But overall it's very small, and hey, that is my first ever machined part. No other tutorial parts, and I'm pretty pleased about that. And it would technically fit if the back part was machined a little bit better. But there's someone to blame there, not gonna say who. I then wanted to try something rather interesting. Is this a precise piece of stock? No, absolutely not. However, it will work for what we're trying to do. Okay, going down. Why is it not spinning? Okay, we're going. You know what? This isn't actually going to use that much stock. I think I trust it enough. Let's just go straight to the acrylic. I do very much want to figure out how I can get this to work though, so I'll do some research because I have a lot of scraps that I can melt down into stock like this. This is the exact reason why I purchased a benchtop oven a little while ago, so that my PLA and ABS scraps and projects that I've accumulated over the last 5 years can be reborn into something useful instead of wasting away. Once I get Air Assist up and running and learn more about the feeds and speeds, I think this will be an awesome approach for prototyping. Yeah, we can see the cut! I probably should have used these settings for the PLA. That looks absolutely beautiful. I have super high hopes. I mean, I've put so little time into Fusion 360 Cam and I've already gotten these results. The bore function is really cool. Yeah, so we're doing a 3mm bore, but using a 2mm bit. It didn't go all the way through. We can see each of the holes. That is so cool. The part is taking shape. So I'm just going to spoil it. The big aluminium blocks from the start of the video is for actually machining a vise. For now, this is the best work holding thing I can come up with. Nothing for the tool to hit at all. Let's cut this out. And I know for sure that that fixture, whatever, could be a lot stronger. That's where custom fixtures come in or whatever. I definitely didn't use a setting that I was supposed to. Okay, I'm just going to run that again. Actually, aside from the middle rectangle being a bit imprecise, I think it's safe to cut out this part. Forgot that it would break free. Well, it's like 70% there, but it's unfortunately not usable. Now we just need a break. Oh, that was easy. And then I guess we can file down the remaining piece. Well, that took long enough. We finally have our first broken bit. I think it's definitely caused by the feeds and speeds being subpar, and the acrylic must have gummed up or done something to it. The bit is absolutely caked in acrylic. As for the part, it's looking a little bit melty, which makes sense. I need to actually do some proper feeds and speeds learning. I have sort of been winging it this entire time. That's my fault. And there we go, it's only been another day or so, and I can break this off, and then we have our part. I wonder if primer clear coat would help. In the end, I ended up with one failure with the arm, but the second part, and my third ever machined part, was a success. I'm very pleased about that, even with the silly mistakes that I made. Yeah, that's a bit much. Well, that's really unfortunate. I was a little bit too hasty with the clippers and ended up basically exploding the part. That's quite a lot of time gone. I actually don't know. I can make it again, but it would use up every millimeter of this stock. So I should have expected this would happen, but at least the tolerances are all good on these parts, so I think we should just go for it and make them out of metal. It'll be good to test the metal on a simple 3-axis part before we go on to the rotary stuff. Now, this would have normally been fine, but I was forgetting one teeny tiny detail. But rather than spoil it, let's see how well my first attempt at machining aluminium goes. Well, not sure how to say this, but much like the previous video where I made a silly mistake by not checking something, same instance here. Now, all the research I did was to get the right sized tubing for the machine, and I did. The only issue is the adapter I bought for the air compressor, which I got 2 of, is for the wrong size tubing. It gets more amusing as that was not the teeny tiny detail that I forgot earlier. That's still on the way. This supports an 8mm ID tube. I have an 8mm OD tube, so just getting something a bit mixed up there. Not ideal. And very frustrating because of all this hype, all this setup, all this everything. That's what I get for not triple checking. At least we still had the cutting fluid. Okay, this is my first time ever machining aluminium, so I'm a bit on edge. Alright, it's looking and sounding decent so far. These chips have now cooled down, so it should be safe to vacuum up. Let's replay that one more time. If I fixed that stock any better, I likely would have destroyed my laser probe, which would have been costly. Thankfully, this is the only close call of that sort. However, immediately afterwards, to prevent such an issue again, I cut and faced the stock to be a lot smaller, although I wasn't exactly sure of the best way to do this. I then went straight to the thread function and got my M3 thread mill ready, although M3, that just doesn't sound quite right. Somehow, I had went on autopilot, adjusted literally everything for M3 hardware, but not realizing that that erases the point of all the M2 hardware that I had bought. This time-lapse is the last clip I have of the metal, as I finally realised my mistake, alongside a much worse piece of info, that I didn't even complete the part as is. There must have been some micro misalignment, and that wasted an additional day's work or so. That's attempt 2 of the same part failed. Now, attempt 3, desperation called, and that sliver of acrylic stock that I had left was theoretically my only shot at a redemption. After the bit made contact with the clamp, causing a bit of damage, I knew it was time to give a custom fixture a go. By no means was what I made anything notable, but it was a pretty satisfying process, and technically speaking, it did work very well. I then began the finishing pass, and... I really don't know what to say now. I've been at this for so long, and it just broke. That's a problem. An unsupported area meant that when the tool cut into the plastic, it once again, like the first attempt, chipped and shattered. Attempt 3 was a failure. I had one trick up my sleeve that I didn't want to use, but in this case, I didn't really have a choice. I wanted to use those heatset inserts, so I did the unthinkable. This was meant to be a subtractive only video, but given I had lost about 5 days of work at this point, it was time to do what I do best. And here we are, a nice ABS glass fiber part. Should hopefully work, and now we can move on to the rotary stuff. So the thing is, I don't know how long this is actually going to take, so I hope it's not super long because it might be a bit too loud to run overnight. But there's like 12 hours left in the day, so let's hope. After flipping the jaws in the vise to accommodate the smaller stock, we were ready to install our 10mm brass rod. Overall, and fortunately, the rotary workflow is actually very straightforward. This was quite the win, as any complications would have pushed me further behind. Will it survive the leveling though? Yeah, that was fine. Okay, here we go. All right, I'm definitely a bit nervous. I'm just gonna leave the camera and come back when I hear something. Hold on. Maybe it has started. It's just that slow. No, there's no way. After no progress for several hours, or at least upon realizing this could take days, I cancelled the program and switched to a metal engraving bit that Makera provides. While not as precise as the crazy 0.1mm bits that I had, they'd still be fine. I was going to try my fine 0.4mm bits and such, but turns out they all had 4mm shafts, and I only had a collet for 3.175mm bits. Another mistake added onto the list. It was around now that the gear's teeth were becoming visible, so it was time to get the camera on hand and capture some brilliant shots. This was one of my favourite parts of the whole project. For my first ever rotary part, not even doing the tutorial, I'm very pleased with that. There wasn't really that much effort into doing this part, to be honest. Sure, there was a bit of fooling around, but like, minimal effort. That's amazing. And not a lathe in sight. Very nice. With the first gear complete, it was now time to move on to the filament gear. This was something I was very curious about, as I would like to make my custom gear for my other custom extruder later down the track, so this practice was going to be pretty useful. The roughing pass went well to cut the stock to size, so it was now time to cut in the actual teeth. It's interesting seeing how detailed the part looks in CAD, and even with a close-up like this it still does, but in reality the teeth are very, very small. It's turned out nicely, and even having designed these myself and having experience with them, I'm still shocked at how small these parts actually are. We've only got one more part left, so let's cut this one and tidy up the workspace. Good enough. After the success of the first 2 gears, only one remained, although it would be out of acrylic this time since the peak plate I had unfortunately wouldn't work on the Rotary. At least the acrylic would suffice and still look cool. It was also a chance to see how square stock would perform on the rotary axis, since I had only used round stock up until that point. Do you see that? That is absolutely beautiful. Alright, now it's time to do the other one. Alrighty, and that's about as perfect as I can get that one. Not bad at all. Sweet. Oh, the brass one looks amazing. Can't wait to polish that. And this is the part so far. You can see it just needs a little off the top. So it's quite a tight fit, but it's press fit, and that's exactly what I want because I don't want this to slip. So let's move on to the next piece. So unfortunately the fit's fine, but it does spin. So I'm gonna have to get some glue then, but I don't have any, so I'm gonna have to buy some. Okay, I really hope this is in the center. We're about to find out. It's unfortunately broken through the sides there. That's really unfortunate. I mean, there was a chance that could happen, and it was really, you know, a fraction of a millimeter off. I'll see if I can bend them back into shape. Well, I'm just going to use the handsaw, cut these, and then sand them down while this is running the finishing pass. Alright, we've got our parts now. We just need to remove this from here, and then I'm thinking we can take the machine and put it over on this little set of drawers there. Yeah, there we go. Well, at least this part turned out pretty cool, right? Even if we need super glue to make it stay. Those teeth are so fine. Yeah, they're a bit small, and this is them compared to some nice M3 ones. Well, to say I'm frustrated would be an understatement. I just destroyed the entire brass piece when trying to tap it. It's not that I can't make a new one, it's that I'm, you know, like 10 days behind schedule. Alrighty, time to fire up the machine. I really hope this works. What also happened was the destruction of the filament gear. When trying to sand it down, or whatever I was trying to do, it pushed the metal down and basically ruined the surface. A new one was in order, but with a different approach. Carrying on with my good luck, I then broke my second bit, a nice 25mm long one. I set the cut depth incorrectly, and snap, it was over. Thankfully, a few spares are included. The approach in question is machining the stock from the stock. This should theoretically get us the best tolerances and a perfectly central hole. In the future I'll just buy stock with pre-drilled holes or something, unless recommended otherwise. Any feedback would be greatly appreciated on this project, as the skills are pretty important to me for what's in store. Okay, I really hope this works. I've only done thread milling once. Oh, that sounds promising. And that's it. And it works! I then plowed the bit right into the new part. You have got to be absolutely joking. Okay, I deserve that for being super ignorant. I didn't re-level the Z. That's completely my fault. There were quite a few ups and downs to get to this point, but it was now time to start the assembly. I sure hope nothing unexpected happens. Dude, are you seeing this? Like when I spin, but let me get it aligned. Oh, the tolerances are really tricky. Okay, now we just install that on the front. Hopefully it should fit. Hold on, it doesn't like something. I seem to have gained a metal splinter or something, so I'm gonna put this on pause for now and fix that up. Unwillingly, the splinter and I became close friends for the following week, and my genius approach of drilling out the filament gear destroyed it, and with the hole for the acrylic gear being quite eccentric, it was also as good as destroyed. This filled the bar just shy of calling the project quits due to the lack of time and dwindling materials, but like every other project, I pushed on. I think I was operating around 3 times more effectively than when I had started, with both parts being completed before the evening. The assembly was now complete, so it was time to hook up the motor to the mainboard and see if it all worked. Fingers crossed. Alright, moment of truth. We've got our extrusion here, 50mm at 1mm per second. Let's push it. Oh, wrong way.
Oh, wait, I think it's working. I think it's working.
3, 2, 1. It's moving, do you see it? Zoom in, zoom in. I should have grabbed a higher torque model. That's also because of the absolutely terrible filament path, by the way. Someone did comment on the filament path. Yeah, definitely something for V2. I was gonna write this off, by the way. This project going in the bin. But wow, we got something working. It even has a metronome function. It's pretty fast when it engages. That's awesome. Yeah, definitely an issue with the parts being a bit eccentric. So the good news is it absolutely does work, and the thing is the filament path is very bad, as I touched on earlier. So if we can improve that in a version 2, this could be functional. But you know, the main goal here is to make something a little bit crazy and learn a lot along the way. This is awesome. While I showcase the final assembly, I think a small summary is in order, starting with what went wrong. Despite CNC machining being a whole lot more precise than 3D printing, I did not add any tolerances to my design. I also made several work holding mistakes, like any beginner would, alongside forgetting to tick a few boxes in the cam. I didn't triple check my leveling sometimes, which could have been catastrophic. By not doing proper research, I lost several hours with the tools just cutting air instead of the part. I also became blindsided with that whole M3 and M2 ordeal, losing over a day of work. I rushed and destroyed several small parts, bought the wrong tools, ran out of stock, and made quite a few costly mistakes, although more on the time side of things. Adding on to this would also be not going with a version 1 design, which I did this time round. It's just shy of a miracle that I made version 1 work using tools I wasn't familiar with. I learned a good deal on stock and how to save time in cam, but ultimately this was all a big reminder to double check things and think them through in higher detail. To lift the tone a bit though, I had lots of success without major friction. The learning curve was realistically not hard at all, but still present. That was really emphasized when I ditched the tutorial stuff and jumped straight into the epoxy back part. Depending on the perspective, I broke only 3 bits. I upgraded from theoretical knowledge on stock, fixturing bits and such to gaining real-world experience, which simply doesn't compare to YouTube knowledge hoarding, which falsely inflates my ego. A few other little wins like clear coat on acrylic, superb resolution of the DIY gears, easy thread milling, and something I really want to drive home is that this was, albeit time consuming and a tad difficult in some areas, it has been some of the most fun I've had making something in a long time. It was almost refreshing and 100% satisfying at times, like when milling metal or facing materials. It's something I truly look forward to learning more about and getting used to. If you're curious about CNC machining and specifically what Makera can offer you, there's a link in the description with a discount code as well. Now, there is one more thing. This is the smallest extruder, right? Right? Have I been outdone by EZ3'd? Ouch, sorry mate. That means I've now had a crack at designing my own hot end extruder and played around with many different areas of 3D printing, alongside a few other things. The custom 3D printer journey is now on the horizon, and I have the skills to give it a go. However, all we can do now is just wait for the sun to rise. So in the meantime, as always, thank you so much for watching, and hopefully I'll see you again soon.